Hello, everyone. Welcome to this season's first AMA session. I will be your main host, helping ask questions, encouraging conversation today. I'm Sarah Grant, and unfortunately, I have to have my camera off because of a bit of a slower internet, but hopefully everybody else's shining faces can make up for that. Today, we're talking about potash mining, Nutrien Limited, and the role that geoscience and engineering has in it. Potash is a potassium-containing salt that is used as fertilizer. Most of the world's potash comes from Canada, with some of the largest deposits found in Saskatchewan. Nutrien is the world's largest fertilizer and crop input producer and service provider. They have 6 potash mines in Saskatchewan, I believe, and an extensive transportation and distribution network across North America. Joining us, we have Craig Funk, who is the Director of Geoservices and Land at Nutrien Limited, where he supports the potash mining business unit. He studied at the University of Saskatchewan, where he earned a BSc in Engineering Geophysics and an MSc in Geophysics. He's currently both a professional engineer and geoscientist. He has worked in hard and soft rock mining, geotechnical consulting, and upstream oil and gas through a variety of locations, such as in South Africa, United States, and Canada. Craig started at Nutrien in 2008 as the chief geophysicist and has progressed into the current role where he oversees potash exploration, mineral and surface lands, corporate disclosure and reporting, and geoscience applications and special projects. And we also have Mark Buchinski, and he is the Director of Mill Process and Pilot Plant at Nutrien, where he supports the potash business unit. He studied at the University of Saskatchewan, Canada, where he earned a BSc in chemical engineering and is currently registered as a professional engineer in Saskatchewan. Mark started at Nutrien in 2009 and since has held several roles of increasing responsibility at various sites in the areas of process engineering and operations. In 2020, he progressed to his current role where he oversees potash surface operations optimization, process engineering, and process controls for all 6 of Nutrien's potash mines. So thank you for joining us today, Mark and Craig. We really appreciate you volunteering your time to do this. And to start off, we are just going to watch the video that you've provided about Nutrien's potash mining process. And just as a quick reminder, please remember if you have any questions, either raise your hand or drop it into the chat as we go along so that we can really get this discussion going.
Okay, I'm going to attempt to play this video, and I will also hope that you can hear it. So once the video starts, please let me know if it's working. Here we go.
Okay, and so let's go into the discussion now. So I want to start things off with a question for both Mark and Craig about what is the role of geoscience for the mining of potash and the day-to-day process?
Yeah, sure. I can start off with that. Good question. So maybe the way I'm going to answer that is the role. It's I'm going to focus more from a employee aspect, or your geoscientist working for Nutrien. And to start, it really depends where you are. If you're at one of the operating sites, like you saw the video there, or if you're working in the corporate office. So if you're an operating site, and we have geoscientists at every operating site, essentially what they're working I think, almost always in the underground environment, supporting the underground operations. And what that might look like is, first of all, of course, we have our production targets that we're trying to make every day and every month. And so as they're mining in certain areas, they'll run into what we like to call in geology, interesting geology. And whenever someone in production hears that, that's always a bad word, because that means that they're not going to be getting as much production out of that area because you run into something interesting. But then, of course, you're leaning on the earth scientists. Basically, the production folks are looking to the earth scientists to help them understand at least how to get through those areas, still mining as much ore as possible. And also, the most important thing is doing it safely. And so from the safety aspect, you just want to make sure that your what we call our ground control measures are working properly and that you understand the geology. That's always a multidisciplinary approach. So you're going to be working with engineers and whatnot too in those areas. So that's kind of the one side of it for the geologists that are supporting the operations and the production. But at sites also, there's often a lot of project work going on, whether that's drilling projects or a big focus of what the earth scientists are doing at sites too is really helping with the risk, like geohazards. And so there's a lot of proactive work there done to make sure that we fully understand the geohazards that we're going to be encountering, and that we have the right measures in place to de-risk them fully. So that's kind of at the operations system, really, really rough. In the corporate environment, which is where I am, here, basically what we're doing on this side then is exploration is one of the big tasks. So often running exploration programs, in a sense, like the geologists, geophysicists almost function as project managers, you could say. And so making sure they're really taking full ownership of the projects. So making sure they're executing as they should, that everything's moving smoothly, and then getting involved in all the QC, QA of the data, working with the consultants and the contractors that are bringing it all in to us. And then we're, at the end of the day, involved in interpreting all those results and giving that back to the sites in a form that they can use to do their mine planning. And then there's a strategic aspect to it too, of course, with exploration, that you're looking at the long-term strategic expansion of the mines. And so you're going to be picking up mineral rights, you're going to be picking up leases, so you can expand and grow, and then using a very long time frame for that. And then coming into that, of course, in the corporate environment too, is again, the geohazards is very, very important. One of the biggest risks that potash mines face, because as you mentioned at the start, potash is a type of salt that dissolves in water. So if you get water coming into the mine, that can be quite damaging to the operations. And so our best approach for dealing with that is to avoid it. And we have a bunch of geophysical systems that we basically use to identify those risks and effectively mitigate them. So that's kind of a 100-mile view on my part. I know, Mark, you're on the chemical side. You want to add anything, or that sound about right to you?
No, I think that you speak much better to the role of the geology and geophysics in this than I do. So perfect.
I mean, the one role where we actually cross over is a portion of what we do too is this is more on the technologist side, but for our reporting and for tracking ore grade and things like that, we're always gathering samples, and that actually goes up through the mill and to the lab there, and that's where they do all the basically full characterization of the samples and the grade and whatnot. So that is one area where we cross over. Yeah.
Great. And is there any sort of particular background or training, educational training, that benefits geophysicists and geologists looking to get into a role such as that?
Yeah, that's interesting because generally the way I look at it, for example, is I like to have kind of a diversity of experience. And so on the geophysics side, I mean, most of the geophysics we use, you do learn in most of the geophysics programs in Canada. The geology side, like we've got geologists that have come through more of I guess, a mining education, but most of them have been more kind of petroleum, just because it's Western Canada. But certainly having some knowledge in mining is helpful, and rock mechanics especially, is helpful too, because you deal with all these things. And honestly, I think what I find, at least with the geologists especially, is that they tend to be have a pretty broad kind of understanding of these issues, and that helps a lot. And then on the geophysics side, there's a role for all the different disciplines, really. We do a lot of what the industry will call near surface geophysics, although we're doing it a kilometer underground, but that's a big part of what we do from day to day. So having and then you have to kind of be able to speak all the languages in geophysics, I guess, whether it's seismic, EM, that's the basic wave equation, or the electromagnetic propagation kind of thing, Maxwell equations. But then beyond that, it's all the different methods. You really pretty much use them all. So I don't know. Hopefully that answers your question, Sarah.
Maybe she was blown away by your answer, Craig. I think she left you speechless. But maybe I can chime in here. Looks like we have a couple of questions that have come into the feed. And here's a question that Stephanie asked, and maybe it'd be best answered by Mark, because it sounds like it's more on the processing side. What is your position on greener reagents that may be priced slightly higher than traditional reagents?
Yeah, like, I mean, we are always evaluating different reagents that we can use in the industry for a variety of different applications, right? So there's, close to a dozen different reagents that we would normally use in a mill on a daily basis, sort of thing. And part of some of the work we do at the pilot plant is to evaluate them for effectiveness and cost, and looking for more environmentally friendly, sustainable type reagents as well too, right? And so that's a balance we have to strike between the gives and takes of each of those, I guess, sort of thing. And certainly we don't make these choices based off one of those criteria only. We're always looking to find the best balance between the most sustainable and environmentally friendly reagents that are effective and do what they're needed in our process, and are reasonable cost, I guess, sort of thing. So we do our best to kind of balance all three of those, I guess, different strengths and weaknesses of them, I guess, sort of thing. And there's no perfect answer for them. It's just we definitely do put weight towards finding more sustainable reagents as well too.
Thank you for answering that, Mark. Maybe just to follow up on that, typically within Nutrien, when you're evaluating some of these new products, how does that go about? I'm assuming you have a pretty big R&D group within your company. Is it something on a monthly kind of time scale, or annual, or how does that kind of the science R&D side of things get conducted within your company when evaluating alternative process products?
Yeah, no, it's there's no, I wouldn't say a time scale. I guess it's more of a continuous, research, R&D, continuous improvement work to try and improve in those areas, right? And so we're always working and talking with the various vendors and suppliers and all these types of things in the industry, and working with our R&D group and their R&D groups to identify potential future reagents that are going to be more effective in each of those areas. So once we kind of work together and identify one, normally you would move to some sort of a lab scale / pilot scale test facility that we would do at our pilot plant, and we would test it on a small scale to see how effective it is. You know, if it passes kind of general, you know, those kind of first pilot lab scale tests, we might take it out and do, you know, a small pilot scale trial at a facility, and if that's successful, you know, then we would look at doing a full operational trial of it at one of our mines, sort of thing. So that's what that normal process looks like, and it's something we're working towards every single day, I guess. And as we speak right now, we're doing some tests at the pilot plant to identify new reagents that meet those needs. So
Excellent. I'm sure that, yeah, Nutrien, you know, being a pretty prominent company in the potash industry, you guys are kind of at the forefront of technology innovation and things like that. Maybe I can shoot it back to Sarah. Looks like she was disconnected for a little bit, but looks like their internet's up and working right now.
Yeah, I'm back. I apologize for dropping out. I did manage to hear the answer, and Craig, thanks for answering earlier, and Jeff for jumping in. I just have a bit of a broader question, a bit of a step back, I think. What is the process for the formation of these deposits, both geologically and, if we dare go there, chemically as well? Where do they come from, and how do we evaluate them?
Yeah, well, maybe I can start, and then I feel free to jump in, Mark, if you want to go to the chemical side of things. But yeah, I mean, here in Saskatchewan, so maybe broadly speaking, it's essentially an evaporitic deposit. So you find it in the prairie evaporite, which is Devonian here in Saskatchewan, but anywhere in the world for that matter, you know, they're evaporitic deposits. So just over time, you had some seawater that essentially some sort of a basin that became closed off, and then evaporation started taking over, and then over time, the concentration of the minerals kept going up and up and up until they started falling out of solution, and then you just got these massive deposits of potash deposited. Trying to think all the different time periods where there's potash around the world. I mean, you get it right up to Quaternary in Ethiopia and Eritrea. Those are the youngest potash deposits, and then I think the oldest would be Silurian, if I remember right. I think that's in the Michigan area there. And then ours is Devonian, which is very large deposits too. So that's kind of, and by the way, when it was all being formed here in Saskatchewan, I think Saskatchewan was basically where present day Costa Rica was. So of course it was a lot warmer, but and then things kind of course moved over time. I don't know, is there anything you want to add to that, Mark, just on the chemical side of things? Maybe I'll just throw in that potash is it's like saying oil. It's a very general term, and when you start talking about the mineralogy of potash, there's many different minerals. What we're mining here in Saskatchewan tends to be fairly basic, but you can get fairly complex mineralogy.
yeah, and nothing to add really. You know, our processes were developed after the potash deposits here in Saskatchewan were discovered, sort of thing, to they're developed to match the mineralogy that we found in the area, sort of thing. So a little bit less historical significance, I guess, sort of thing, than the original formation of deposits.
Yeah, maybe I'll just throw this in too. There really is no present day equivalent of what's going on, or what happened here in Saskatchewan. It was just such a massive deposit. But I mean, one area where present day production is coming out of basically a process that's happening is in the Dead Sea. So both on the Jordan side and the Israel side, they're actually producing potash out of the Dead Sea. So it's maybe one way you could look at a modern equivalent.
Great. And so what is it about the potash deposits in Saskatchewan that's so unique?
Sure.
That's enabled us.
Looks like you might be having a little bit of problems with your connection there again, Sarah, but I think what you asked me is what makes the deposits here in Saskatchewan so unique. And was that right? You're still there?
Yeah, it sounds like maybe yeah, maybe the question was, yeah, why Saskatchewan? Why are we the breadbasket of potash
Yes,
production in the world?
I'm here.
Okay.
That
I like to call us kind of the Saudi Arabia of potash is, I guess, the way I look at us. But yeah, it's just the massive deposits here in Saskatchewan are just so enormous, and Saskatchewan kind of won the lottery on potash when during Confederation, when the boundaries of the provinces were drawn up. We just happened to get all the potash, so it kind of Alberta's got a tiny little portion of it, not very, probably not economic, and then there's some that spills into Manitoba and then South Dakota, but by far the largest economic portion of it is in Saskatchewan. So what makes it particularly unique is, you know, if you've been through Saskatchewan, you know how flat Saskatchewan is, and surprise, surprise, it actually continues through all the way down. So very flat as you get down. And what that makes for is just very economic mining. So you have a massive kind of very tabular ore body, very consistent grade, very predictable. And what that allows us to do is to mine it in a highly automated fashion. And so just it allows us to get our costs way down, mine very large quantities very cost effectively. And so that makes us competitive on a world basis. And there's, you know, depending on the potash deposits, as you know, you get, you know, the tectonic side of things. So you get in two broad categories. You get stratabound potash, which is what we have in Saskatchewan here. And then you get haleokinetic potash, which has been modified through tectonic processes. And because potash itself, you know, salt is essentially like silly putty. Salt behaves like a viscous fluid over time. Potash is even more so. So if there's any kind of tectonic activity, it'll preferentially flow along the potash seams. So where you get tectonics, then it gets highly altered. And in some cases, then you can still mine it, but you have to mine it in a different way. So it makes it more expensive.
And while we're on the topic of mining it, maybe you can speak about geophysical tools that are used in the exploitation side, or even the safety side of things when you're building out these mine shafts. I'm assuming that you might run into areas where you could have dissolution, potash being pretty soluble. How do you avoid these areas, and what are the type of tools that you use for this?
Sure. Yeah, maybe I can start off with on that one. You touched on that, which is really good, and that is the inflow risk. And so actually the most mature potash mining area in the world is Germany. They've been mining potash there since the early 1800s. And if you look at their history to date, they've had over 250 mines, and almost half of them experienced some sort of an inflow. And I think 30% of them, the inflow was so severe that the mines were lost. So, you know, when you look at our mines here, where to build a mine and get it running is going to be $10-15 billion, you know, like billion with a B. That's an enormous asset, and there's very few companies in the world that can really even afford to do that. And so once you've built that mine, you're going to want to make sure you don't flood it. So that's where geophysics comes in. And maybe even before I'll get into that, I mean, just potash deposits around the world were mostly found through oil and gas drilling because they're all in sedimentary basins. But then where the geophysics come here in Saskatchewan is, as you mentioned, Jeff, being the prairie evaporate. If any of you have ever worked in Western Canada, you know, you get salt collapse features and things like that. So we use traditional seismic, works very, very well for us. As it also ends up, we don't really have the coal seams and everything here in Saskatchewan, so our seismic data is exceptional. We have frequencies 150 hertz and up, well, 130 to 150 and up, I guess. And so it makes it for very good seismic data. And so those big kind of mine-killing georisks are pretty easy to identify on seismic. And so how we deal with that then is we've got kind of standard procedures for planning on our mines. You know, those are deliverables that we give to the mine planning department, and then they plan accordingly. The smaller features, though, as you know, with seismic's always getting better. You're getting more and more resolution out of it. But the small kind of disturbances, as I mentioned before, we can't necessarily see with the seismic data. And so then that's where the other geophysics comes into play, which is more the near surface end of things. And so we'll use our main tools there will be ground penetrating radar, electromagnetic surveys. We also do high resolution seismic in the mine, depending on the application. And then I'll add to that too with the GPR. GPR has been something that has really was introduced in the industry in the 1970s and used it quite a bit ever since, all the different frequencies too. And it is actually an effective safety tool for us because it works so well in salt. Salt has a very low dielectric constant, so tends to travel a long way with little attenuation. And for us, one of probably the biggest safety risks that we deal with underground is what we call ground falls of ground. And ground penetrating radar is one of the tools that's actually quite effective at indicating whether an area may be ground fall prone or not. It's one of our early indicators. So we actually have ground penetrating radar technology that's incorporated into all of our mining machines. So we're collecting basically as we mine. It's actually a standard, like a mining standard for us. It's basically required. So as we're mining, we're collecting ground penetrating radar, and we've got applications and whatnot that are used to detect when there's potentially safety threatening geology, and then appropriate action is taken at that point. So we've got geophysics incorporated literally right at the mining face, and that is the most dangerous place to work in a mine. So yeah, so there's a long-winded answer. Hopefully that I think that's touched most points.
No, thank you. That was a really in-depth answer, and yeah, I think that covered what we were looking for. Maybe we can step into kind of a case study. I know offline between the four of us, we had talked about one of your a chemistry study that you guys undertook to figure out how to deal with these clays. Maybe Craig, you can kind of start off with speaking about that a little bit, and maybe Mark, you could give us the overview on the processing aspect of how that was done and how that actually ended up in contributing to higher yields for Nutrien. I just think it's a really good example of this cross-disciplinary study between engineering and the geoscience side.
Yeah, that's the cool thing about being more on the operational side of things. So, we're very much more operational focused. And one of the challenges we've always dealt with in mining underground is the clay seams. And so there's quite a few clay seams. If you watch that video at the start, there's a point where I think they point them out. And that actually creates ground control challenges for us. The ground tends to move preferentially along the clay because it's so soft. So one of the things we had pitched around for a long time was doing a proper assessment of these clay seams. And as long as I've been in the potash industry, it's always something we had in the back of our minds. So what we did a few years ago is put that out as a research question, actually through the MyTax organization here in Canada. They're a nonprofit that basically helps you find funding to do research. And then we were actually lined up with a postdoc student out of Queens. He'd worked in the oil sands for quite a while, very knowledgeable on the periovaporate geology and the chemistry. And so we brought him in, and then we also coordinated with the Polytechniques to collect all the clay samples. And then we brought in a few more geological students to help with the analytical side of things. And then using Queen's analytical capabilities, we fully characterized all the clay, basically chemistry. Basically just to understand it better and to understand the diagenesis of it, and how, if it gives us some indications as to basically how this deposit formed and how the clays got there, and if they can tell us anything about what was going on in the Devonian in Saskatchewan here at the time. So a lot of interesting results that came out of that. And of course, part of what was driving that too is it is challenging for the mill. So I'll let Mark kind of take over from here and talk a little bit about that.
Yeah, no, that's it was definitely a valuable study for us in the mill as well too. I would say historically, in sort of potash processing terminology, we kind of talk about potash, salt, and insols, right? Which was kind of the bucket that we just lumped all the sorts of different clays together into. So we basically had historically kind of classified it as basically anything that isn't soluble in our water as being clay and is detrimental to our process, and we treated them all the same, even though there was multiple different types of clays and whatnot. So the results of that study, we were able to really point some research at what we may kind of think to be the problem clays that cause us troubles with recovery and product grades and things like that in our mill. So we can actually we're actually doing the research so we can select reagents that would, you know, preferentially depress different clays more effectively than other ones. And, you know, some might have different surface charges than others. And so it's really enabled us to really start down the research path that we need to kind of really be able to effectively depress those clays, as opposed to just treating them all as one uniform, I guess, kind of impurity in the process.
Awesome. Yeah. Thanks for sharing that case study with us. We actually had a couple audience questions that came in. So maybe we can jump to those for a little bit here. We got one from Brian, and this one could be either Craig or Mark, whoever wants to jump in can. I'll just read it word for word here. You said that almost all the potash is exported around the world, where it is presumably combined with phosphate to make various products. If you had a source of phosphate in Canada, would you make fertilizer and other products domestically?
Maybe I think Mark might have to answer most of this, but the other key element in fertilizer is nitrogen, which is also produced in Alberta, by the way.
Yeah, and I guess I'm not an agronomist or a agrologist or anything like that, so it's certainly not my area of expertise to talk in terms of yeah, I guess what exactly works the best for our farmer customers around the world, sort of thing. But I think you know, it through our retail networks, there are all sorts of different blended fertilizers that are available to be bought, right? And you know, how that would fit into, you know, our total value chain from you know, mining it underground to processing it, to getting it into a train, to getting it into a blending facility, to getting it to our customers all around the world, if it's domestically or internationally, would be hard to say without doing a pretty in-depth study at this point, sort of thing. But you know, it's an interesting question, and one that I don't have a great answer for, but yeah.
Maybe I can just throw in too, geologically speaking, the biggest phosphate deposits in the world are in Morocco, and that's where a lot of the world's phosphate comes from, although there's phosphate production in the US also. I'm not aware of any in Canada. Doesn't mean that there isn't, but at least phosphate for fertilizer.
Excellent. Maybe we can get more into a question surrounding what one should, you know, how should one prepare in university or in their early career? And maybe what we'll do is, maybe Craig, you can speak to the geoscience side, and Mark, you can speak to the engineering side. But let's say you're a student, you're in university, you're taking courses, you know, you want to get into the potash industry or the mining industry for that matter. What are some ways to develop some skill sets that could be useful in a professional setting? And maybe you can start off with that one, Craig.
Sure. Yeah. It's a good question. And I think to start with in you know, mining, there's just the demand, you know, there's this whole thing, this whole concept of critical minerals around the world. And critical minerals, what that really means is if the supply chain is disrupted, those minerals would not be available, or it would be hard to come by. And so here in Canada, at least, potassium does fall into the critical mineral category. So you look at that as a whole, you know, everyone's probably heard about lithium, for example, and the demand for lithium, but you know, it's a whole chain of minerals that are going to be needed as the world kind of pursues an energy transition, you know, from copper all the way to these very niche kind of rare earth elements and whatnot. So I think it helps maybe just to have at least the demand in the mining industry. And honestly, if you're a geoscientist and you're human and you breathe and you eat, you can probably find a job in mining industry at some point, because there's just going to be such a massive demand. There was a news article that came out last week. You can find it on the Canadian News, where they were saying in Saskatchewan alone, I think by 2030, we're going to be short 5,000 workers in the economy here. Most of that's being driven by mining. So mining is the biggest industry in Saskatchewan. And when they talk about being short, they just mean, many different, trades, everything, accountants, you name it. But like the earth science mining side of things is really falling short in that area too. And I think, what I've heard, at least talking to other folks kind of internationally, one of the things that's been on the geophysics side to geology to some extent is the mining industry has, just like oil and gas, mining industry has a bad reputation. Extractive industries have a bad reputation. And there's a real disconnect in society between what mining does for society, how people benefit from mining, and energy for that matter too, like the critical role it plays in society, and the needs. And so a lot of people in the earth sciences, from what I've heard, are going more into the environmental side of things and not so much into focusing on extraction-based careers. But we are going to be facing critical shortages in these areas. So I think the best advice is to get an earth science education. What I did, for instance, when I went through school, one of the things I did is I also augment your education with some other things that might be helpful. So I took a specialization in rock mechanics, and that really served me well. I also just the soft skills. Like I've always focused a lot on communication, like being able to communicate well, written and verbal. That'll take you really far in your career. And that's, I'm just throwing it out as an example, but there's so many things like that. I think today in any industry, really well-rounded people are going to find jobs, really. My thoughts, Mark?
Yeah, no, and I think you hit it on the head there. Like would echo your comments around just, the mining industry in Saskatchewan is really, and the potash industry as well too, is just really booming right now, and there is lots of jobs. So if you're interested, apply, right, and get your name out there. And I know when I was a student, I did summer jobs and internships with various different mining companies, which really served me well too. So keep eye out for those type of things as well too. And then we really just echo the rest of what Craig had said there, sort of thing. So
awesome. Well,
just
thanks
to
for that,
jump in.
advice. Oh, sorry, Sarah.
Oh, that's all right. Thanks, Jeff. Just to jump in, I kind of wanted to ask Mark a little bit more from the engineering perspective, also what sort of focus or skills or majors are a good conduit to this industry.
Yeah, well, they're complex operations, right? And so we hire a wide variety of all different engineering disciplines. Like I myself am a chemical engineer, Craig's a geological, but we have, mechanical engineers, electrical engineers, environmental engineers. I'm missing others. There's a very wide variety of them. So there is, for all different disciplines and skill sets, there's different jobs for them, right? And in terms of specific skills, I think I can speak for myself anyways. I've always found and similar to Craig, that a lot of what we do when we get into a mine is and most new graduates and whatnot do start in a operating setting as opposed to, say, a corporate setting. And normally you kind of come to the corporate setting after you've had a significant amount of experience in operations. And a lot of that work that people do at the operations is going to be optimizing a complex existing operation. So not only having the technical skills, but also the communication skills, the interpersonal skills, the collaboration skills, the teamwork skills, like all those type of things are critical to success in those type of environments, sort of thing. So, those are skills that I personally put a lot of weight into when I'm looking at candidates and whatnot. So, hopefully that helps a little bit, Sarah.
It does. Thanks, Mark. And then we're just sort of beginning to go more into the soft skills side of this discussion now. What role has mentorship had for you in your career progression, and how has that sort of brought you to where you are today?
Is that targeted for someone, Sarah?
I'll keep it really quick, Mark, and give you time
Sure.
to talk. Yeah, so I'm a bit older, and when I did my graduate degree, I was studying under a professor named Don Genswell. He actually had a huge impact on kind of the direction I took in my career. And he, he was kind of unique, I guess, for many professors, where he really valued industry engagement. And so he worked very closely with the mining companies. And so that benefited me as a student because I got to do kind of projects at the mines. And, for him, it was always about the value proposition. Like, what am I doing? Kind of, he'd ask, what am I doing to make the industry better? And he really modeled that. And so, yeah, just learned a lot from him. And then, even on the communication side, he was one of these more old school professors. And so, I'd have to do like research papers and stuff like that. And my writing wasn't all that great at that time. And remember the first paper I wrote, he just kind of gave it back to me and says, you're going to have to redo it. He didn't even tell me what I did wrong. I didn't write it very well, basically. So he kind of forced me to learn how to communicate. And, again, all those things, have really paid off for me, I think, long term. And even, my initial job, my first job was in the gold industry in South Africa. The reason I got that job is because Don Genswell had developed an algorithm that was used for microseismic event location. And at the time, it was a very efficient algorithm that worked on the computers of the day, which were 486s. And they had that problem of not being able to locate these things very quickly. So that algorithm would run very, very fast in a 486. So the company in South Africa was using his algorithm. So when I applied for a job, they said, oh, that guy's Don Genswell student. So they gave me a job. So, it was tough to get a job back then, actually. So yeah, there's just an example. I mean, I got way more. We're running out of time here, so I'll let Mark speak too, because I'm sure Mark's got some stuff.
Yeah, no, and I think it back, I don't, yeah, I know actually that I've never really had a formal, I guess, sort of mentor-mentee relationship or anything like that, but certainly I've had a lot of really great leaders over my career. I've had a lot of really great colleagues. I've had a lot of really great coworkers and friends, and yeah, just family who have really even sort of just filled that mentorship role for me over my career. And I think the big thing to me, or to me, has been to just have a conversation with those people and listen to them and listen to hear their perspective, which may be different than yours. And I know I've been taught a lot of stuff by various people throughout the years, sort of thing, from technical things too, but also just stuff for different approaches to leadership or collaboration or critical thinking and strategy and all that type of stuff. And I think that's one of the great things with working in the mining environment is there's just you're working with such a depth of different people and backgrounds and ways of working and stuff like that. If you're kind of watching and listening and talking to those people, you can really absorb a lot of great stuff. And I think that's, I think back to a lot of the people I've worked with, they've certainly, I know they've had a impact, shaped how I view different things in my career.
Wonderful. All right, I have one more quick quick question for you, for both of you guys. Uh, uh, well,
Dying to hear this question, but seems like latency could be an issue here. We'll see if she can revive herself there. Maybe she can text it to me and I could ask it.
I think I'm
Oh.
here.
Sorry, Sarah, it looks like you're cutting out a lot. If you could just type it into the chat box, maybe we can relay that question as our ender here and wrap up. Okay, maybe it wasn't meant to be. And the
Looks like
power on my
someone put it in.
laptop is dying. Oh, favorite day-to-day task. Oh, great. Okay. What is your favorite day-to-day task at Nutrien, Craig and Mark?
I'd say mine is the coffee break, but that's probably not what you want to hear.
Hey, it's honesty. How about yourself, Mark?
Yeah, for me, I don't really have a routine. I mean, Mark and I are managers. I have a fairly diverse job that I do. So, what I'd have to say, maybe I'll say this. When we had the COVID thing and everyone was working at home, I always kind of assumed I was an introvert, but I found out I was more extroverted than I thought I was, and I was locked in my basement at home. And so really missed the interaction with the people. And, to be honest, I work with a lot of fantastic people here. And that's probably the thing that really gets me up in the morning, is just working with all the great people I work with, like Mark.
Oh, that's nice. No comment.
No, I would echo that statement, and that certainly one of the in the role I have now, I don't really have, say, day-to-day tasks. It's more in the directing people type of a role and whatnot, and overseeing projects, but certainly coming to work and get to work with the people that we do every day, just it makes it a pleasure to get out, come into the office sort of thing. And I'll if I have an answer on a task sort of thing, I could even go back to some of my days as a more junior person in the company sort of thing. And just being in an operating environment sort of thing, certainly, in when I had a more task oriented role, like one of the things I did enjoy was just going out and getting into the operating environment every day, and just spending an hour in the morning walking around the mill and seeing what the problems were that the operations group had and the problems that the maintenance group had, and seeing how we could add some value to fix those problems and make life better for everybody out there sort of thing. So that was always something I enjoyed, was just that morning walk around, having a safety conversation, having a conversation on just how people's shifts went and what the troubles were, and that type of stuff as well too.
Actually, that's really good, Mark. And maybe just to echo what Mark said, I mean, from a geophysics point of view, it's maybe a bit more unusual for a geophysicist to be in the operational setting, but that is actually one of the things I enjoy the most about my job, is getting out to the operating sites and seeing where the money's being made. Exactly what Mark just said. You're seeing the real problems they're dealing with, and you can't always speak like a geophysicist. I mean, you've got to make it so that they can understand it. But just seeing, what's working for the operations and where they need help, and it's really enjoyable. That's the part I actually love the most. Yeah.
Awesome. Well, I think that's a good note to end it on, and looks like we reached the hour here. Today we heard a lot of great sage advice from Craig and Mark, and so I just want to give a big thanks to them for participating in our AMA, and also just a big thanks to Alyssa. She's behind the scenes, got the webinar up and running, Sarah for hosting, and Jen for helping out. And thanks to everyone else for attending today and taking this lunch break if you're in Mountain Standard Time, and I guess it's 2:00 for you guys in Saskatchewan. So appreciate everybody for joining in on us today. And if anybody has any cool ideas for suggestions on what we should cover in the future for an AMA topic, you could drop us a line at mentorship.cseg@gmail.ca. We also have a LinkedIn page, CSEG Mentorship. And if you want to join the program, you can check us out at cseg.ca and check out the mentorship page and sign up. It's totally volunteer run and free to join. So yeah, on that note, I'm just gonna end the webinar. And thanks again for everybody for